Okay, so what is the ionization energy of a hydrogen atom that is in the n equals 6 state? So the energy for a hydrogen atom as a function of n is minus r over n squared, where r is our Rydberg constant, so 2.179872 times 10 to the minus 18 joules. And I'm just going to migrate that down. Or putting it into a unit that's a bit nicer, 13.6 eV about. But I'll continue to use the joules one. So our ionization energy, I don't know why I put it like that, but our ionization energy is the energy it takes to go from some n state to infinity. Why am I doing this? Okay. It's the difference between our energy at n equals infinity and our end state. So our final is infinity and our initial is n. And so that equals minus r over infinity squared minus a minus r over n squared. So that turns into a plus. 1 over infinity is just 0. And 1 over infinity squared is very 0. So then our ionization energy as a function of n is just r over n squared. So if we want it for the n equals 6 state, then our ionization energy for 6 is just 2.179872 times 10 to the minus 18 joules over 6 squared. So if we run this through our calculator, we find that our ionization energy is 6.055075 times 10 to the minus 20 joules. If we want to put it in EV, which is a bit of a nicer unit, then we would multiply by 1 EV per about 1.6022 times 10 to the minus 19 joules, which comes out to be 0.3779 EV. So that's the reason for using EV, is rather than having these 10 to the minus 20s hanging around, they're more round numbers. Okay, so in the solution given, they determine the wavelength using the Rydberg expression, so that's fine. It's just extra steps. Because after you determine the wavelength, you have to use E equals hc over lambda to get the energy, but it comes out to be about the same. It just depends on your rounding here, so I used quite a few digits on the Rydberg constant, so the values are going to be a little different, but just in the second decimal place. So I say the solution is correct. The method's correct, and I presume the values are correct. It would just be differences in rounding.